Assalamu alaikum. Today it is lecture 7. We are going to discuss maintainability. Maintainability is a design parameter intended to reduce repair time as opposed to maintenance, which is the act of repairing or servicing an item or equipment. So maintainability is uh, how we can reduce the repair time. So if we say it is a maintainable equipment, it would mean that we can repair it and get it back to the useful operable condition. In maintenance, we just say we are doing some act of repairing, but to make that repairing easy, that is maintainability. We would have four objectives to do from maintainability, and these are: number one, the main objective of maintainability is to maximize equipment and facility availability. If we can easily do maintenance, then the downtime would be less and the availability of the equipment would be more. Second, reduce predicted maintenance time and cost by simplifying maintenance through design. From this, we mean that maintainability cannot be introduced into the equipment after it is made. It is introduced into the equipment in the design stage. When we are designing, we take care of those things which we want to include in the uh, steps to do maintenance. We make it easy to disassemble and assemble again. We increase the accessibility to the parts which are damaged. Number three, determine labor hours and other resources needed to perform the projected maintenance. Now, when the equipment is very complicated, you don't know how to open and what to open. It would take long time and it would be unpredictable. But when it is designed for maintainability, you would know everything, how many hours are needed of the labor to open the equipment for that maintenance, how much time for that maintenance would be required, and after that, how much time would be required to reassemble the equipment and close it. Number four, use maintainability data to determine item availability or unavailability. When we want to do maintenance, we would have some data about the equipment, uh, and from that we can very easily tell that whether our equipment would be available or not for production. This is because we have already quantified the number of hours or whatever time it is required for repairs. So everything is under control. Uh, Let us discuss few uh, definitions like maintainability. So maintainability is the probability that a failed item or equipment will be restored to acceptable working condition. Means it is not necessary that when something fails, it may be restored to acceptable working conditions. So maintainability is the term which we can use when we are able to restore an item to acceptable working condition. Maintainability engineering, an application of scientific knowledge and skills to develop equipment item that is inherently able to be maintained as measured by favorable maintenance characteristics as well as a figure of merit. Maintainability model, a quantifiable representation of a test or process to perform an analysis of results that determine useful relationship between group of maintainability parameters. And downtime, the total time in which the item or equipment is not in a satisfactory operable condition. It means you cannot do production with the equipment. Serviceability, the degrees of ease or difficulty with which an item or equipment can be restored to its satisfactory operable state. Maintainability function, a plot of probability of repairs within a time given on the y-axis against maintenance time on the x-axis, and is useful to predict the probability that the repair will be completed in a specified time. So this is about the mathematics in maintenance. We are not doing those mathematics. So mm, maintainability function, we may not be able to use it. So that was about maintainability objectives, and few definitions regarding maintainability. Now let us discuss uh, maintainability, how we can achieve it. So maintainability design characteristic, it is a design characteristic and specific consideration. There are many maintainability related system or item characteristics that must be emphasized during design. Some of these are: number one, modular design. We will discuss this uh, in detail. Interchangeability. From modular design, we mean we make modules uh, so we can identify which module is not working and replace it. Interchangeability means that when we want some part that is easily available and that can be changed in the market. All the standardized parts are available, and when we make standard parts, then we increase the interchangeability. Displays. There are different displays where we show the pressure, temperature, voltage, current, uh, which show the position, the parameters of the uh, machine or the equipment which we are using. So these should be incorporated in order to analyze the working of the equipment. Human factors. Uh, as the maintenance is going to be performed by humans, so human limitations that must be kept in mind. If say some part of the equipment is heavy, so then it should be uh, way heavier than one man or few men can pick, so that it is understood that it should be picked by some forklifter or a chain pulley arrangement. Safety, if the equipment is not safe, then no one would be coming for its maintenance. So it should be made safe to work on. Test points, there are some points at which we test the equipment, we take some reading, and from that we mm, know about the condition of the equipment. So there should be test points which verifies that the equipment would be working properly. Standardization. Uh, if the parts are standardized, they would be easily interchangeable, and its cost would come down and its maintainability parameter would increase. Controls. When you want to say start the equipment, you should have in front of you some displays uh, and the buttons, whatever they are doing to the equipment. So all these controls should be in front of you. You should not be moving for one button from one point to another button to another point. So controls should be accessible. Illumination. If you are doing maintenance and there the light is not proper, you may not do it properly. So illumination, that lighting should be properly available. Weight. Its weight should be such that it can be easily handled. Uh, Say handled by one person, handled by two persons, or use of some uh, equipment for picking it up. Lubrication. If the lubrication is difficult uh, to apply, then it would be failing many times because we would be shying from the job which is not easily done. So lubrication should be at the point which is easily accessible. Accessibility, if you want to access some point on the equipment, uh, how much time you need to access to that? Like you do the maintenance of your engine, so you have to open the bonnet and then you can access the engine. And if you want to do some task inside the engine, you would have to bring it out and do maintenance on that. So just on the engine, it is just picking a bonnet, and when inside the engine you have to bring it out. So it would need more time to work on the engine, inside the engine. So that is accessibility. Installation. uh, Installation of the repair parts and installation of the machinery, both are important. When machinery installation is in progress, we try to uh, put the machinery or the equipment in such a location that uh, around this machine spaces are available for doing maintenance. If you cannot do maintenance in the vicinity of the equipment, then it would be taking longer time for maintenance. Training needs. Uh, Trained people are needed to do maintenance. If some task it is coming after a year or two, so then you may forget what steps did you follow, and it would be difficult. So there should be some training, some revision, so that you remember what are the steps which you would be following when you are opening that equipment. Adjustments and calibration. If you can easily do adjustments and calibration, the maintenance would be coming less frequent. And if you do maintenance, then the adjustments and calibration they should be easy so that the equipment downtime is less. Tools. We need different tools to open different parts of the equipment. Now, those tools should be standard. We can use SI standards or British standards, so it should not be a mix because then we would need a lot of tools. Labeling and coding, all parts should be labeled and they should have codes. Different parts of the equipment they are having codes. So when you want to replace them, you order the manufacturer uh, not showing his the picture of that part, but you just send the code that this is the part which I need. So coding and labeling, that is also very important. Test equipment. mm, There are some equipment which we use while testing, and if those equipments are available, we can easily perform the maintenance and reduce the downtime. Manuals. Almost all manufacturers produce manuals of their equipment in which they mm, inform the user how to use it to get a better life of the equipment, and in case of faults, what are the remedies. Work environment. The work environment where the mm, maintenance personnel would be working, that should be a, a good environment so that uh, enough light is coming on, the temperature is reasonable, uh, mm, visibility is good, everything which adds to comfort of the workers, there is a good environment. Covers and doors. In order to access some parts, uh, you have to open some covers and doors. So if we are not able to open those covers and doors in time, it would be wasting a lot of our time. So covers and doors, they are also very important in maintainability. Size and shape, size and shape of the equipment, and also size and shape of the covers and doors through which you would be accessing that equipment. Failure indication. Sometimes the equipment is failing, but it is not indicating. So we would like to have some failure indicators to know when this equipment is failing and how it has failed. Connectors. uh, the equipment is usually connected, it is integrated with some facilities. So, how you can connect and disconnect uh, your equipment from those uh, facilities and utilities. Test hookups and adapters. Sometimes you want to test the equipment, so how you can test it and what adapters you use for its testing. So, all these things count towards maintainability, and these parameters should be kept in mind while designing an equipment. The most commonly cited maintainability related characteristics by, by professionals involved with maintainability include displays, controls, doors, covers, labels, and coding, accessibility, test points, checklists, mounting and fasteners, handles, connectors, test equipment, charts, aids, and manuals. So, if something was missed, it is now included in this list. Now, let us discuss some uh, parameters which are very important, and number one is the accessibility. This may be described as the relative ease with which an item can be reached for replacement, service, or repair. When you find what is the problem, where is uh, the failure, then you want to replace that or do repair on that, then the question comes how much time you need to access to that point. So that is the accessibility. Inaccessibility is a frequent cause of ineffective maintenance. When you cannot reach easily to that part, then You may not do proper maintenance on that. Thus, an important maintainability problem is accessibility. Many factors can affect accessibility. Some of them are as described below. Number one is location of item and its associated environment. So, where this item is located and what is in its environment. It is a hot environment, cold environment, it is dangerous environment. So all these count. Second, frequency of entering access opening. If you have to access some part through access opening, how frequently you are using that access opening. If it is frequent and this access opening is difficult to open, it needs longer duration of time, then you would be spending more time and accessibility would be reduced. Distance to be reached to access the part of equipment. How much distance is the part away from you? It should be near as possible to you so that you can easily handle it. If it is away from you, it would be hard to handle. Number four, type of maintenance task to be performed through the access opening. When you are accessing through an access opening, what are the tasks which you are performing? It is a screwdriver task, it is a wrench task, or it is uh, some key which you are using. So, how easily you can uh, move that equipment inside that opening. So, easily uh, perform tasks, so maintenance time would be reduced. That would be having good accessibility. Number five, visual needs of personnel performing the task. If the access opening is small, either you can insert your hand inside or you can see it. Then it is hard to do. You should have your visual needs uh, fulfilled. Otherwise, it would be difficult and it would be wasting some time. So, number six, types of tools and accessories required to conduct a specified task. When you are performing a task of uh, maintenance, how easily you can perform that. Next is work clearances appropriate for carrying out a specified task. If you cannot uh, turn the spinner, it is there is not enough space in that location. So the spinner is not rotating there. It means you would have to engage and disengage many times. That would reduce the maintainability, accessibility, and increase the maintenance time. Danger of uh, degree of danger involved in use of access opening. If you are to perform a task uh, behind an access opening, is it dangerous? Dangerous in the sense that are there any high voltage points nearby or hot surfaces? If so, then uh, that is not a proper opening where you would be performing maintenance task. You would have to first make it less dangerous by turning off the voltages and turning off any furnaces which is making it hot. Number nine, mounting or packaging of item or part behind access opening. If a part is on the other side of the access opening which you want to handle and uh, that is mounted in such a way that you have to open many other items before you can access that item. It is then difficult to access, and longer duration of time would be required for maintenance. Next is required time for performing the specified task. Sometimes we use the uh, time measurement tool. That is, we have defined that this task is say of 1 hour or 2 hour. So when time is specified and the task is difficult to achieve, then you get into problem. Type of clothes worn by involved personnel uh, in the industry. We are required to have a specific uh, clothes. If the clothes are loose, then those loose clothes can be entangled in some parts of the equipment and your life may be endangered. So, proper clothing should be used so that the accessibility time is reduced. We can increase or decrease the uh, access accessibility if there is an access opening, then there is guideline how this opening should be. Number one, design access opening for maximum convenience in performing the required maintenance task. I think it is self-explanatory, clear. Maximum convenience is required in performing the required task through whatever opening it is. Design access openings so that they are safe distance from hazardous moving parts or high voltage points or high temperature points. If there are moving parts, there is a danger you may injure yourself. Uh, Injuries can happen to you. Sometimes amputations can happen. So you should be very cautious when accessing through some opening. Number three, ensure that access opening occupy the same phase as associated features such as displays, controls, and test points. Simple. That is when you are working in an access opening, the gauges which are telling the condition of the equipment, they are in front of you. The displays which are perform displaying the performance of the equipment, they are in front of you. The controls with which you can vary different parameters and check the displays, they should be in front of you, near to you, and test points from which you can test the equipment's usability, they should be very near to you. So all these things should be accessible, easily accessible through the access opening, so that uh, it can be maintained easily. Ensure that the location of access opening allows direct access to the part or component, and that will subsequently require some kind of maintenance. So if you open a uh, access opening and then you have to open a lot of uh, parts mounted on that part, and then it would be uh, taking a lot of time, and if a lot of time is taken to reach that part, uh, that is not a good access opening. Ensure that access openings will be accessible effectively under normal installation of the equipment or system. So when there is an access opening, whenever it is installed, the equipment is installed in normal installation conditions, that is easily accessible. Ensure that the lower edge of the restricted access opening is not less than 24 inch, its upper edge not more than 60 inches from the work platform or floor. 60 inches is understandable. That is 5 feet. The part which you want to access, it should not be at a height higher than 5 feet, because your height may be 5 feet or 6 feet or 5.5 feet. So it is at your height, at your eye level, so you can easily perform maintenance task on that. And from the floor, it should be high about 24 inches, that is 2 feet, so that you are not required to lie on ground to do maintenance. So you can do it while sitting. So 2.5 feet or 2 feet is good enough to be above the floor level, and you can do maintenance while sitting. Ensure that heavy parts units can easily be pulled out rather than lifted out. So if you can pull it easily, it means it is easily handleable. And if you have to lift it, then it means that you need some mechanism to lift it, some support. So that is about uh, the equipment's weight, and ensure that location of access is compatible with the height of the work stands and carts that will be often used in the industry. When you enter a big industry, you would be able to see that there are some uh, platforms made, and there are ladders and stairs to access those platforms. And these are made to make the accessibility uh, good, uh, because if it is frequent to reach out to those parts, then you should have some stands to stand on that, or carts on which you stand. So these are common. Some would be movable, some would be fixed to the equipment, so that whenever you need to access that, you can access that part easily. So that was about the accessibility and the access openings. Some parameters are fixed if you want to make an access opening. Then placing an arm through access opening requires 5 inch by 5 inch width. If you want to place arm through access opening to the elbow, then its size can be 4 inches to 4.5 inches. And if you want to insert some component or part, then its size can be 1.75 inches to 4.5 inches. Uh, if you want to insert a closed hand with thumb outside the fist, so 4.25 inches to 5.12 inches, uh, the dimensions would be. Inserting empty hand into opening, you need to have 2.25 to 4.5 inches opening. Next thing, or the important thing in accessibility, is the modularization, that you make modules. Uh, so you are not changing a part, you change the module. Changing the module uh, should be easy, so that you replace the module, and then uh, you make the equipment functional, and you can work on that module later if it is repairable. If it is not repairable, you can just throw it away. So modularization may be described as the division of product into functionally and physically distinct units to permit removal and replacement. The degree of modularization in a system or product depends on factors such as cost, practicality, and function. Every effort should be made to use modular construction wherever it is logistically feasible and practical, as it helps reduce training costs in addition to other concrete benefits. Training cost means that you can train someone to work on a certain module. So the processes which are involved, they are limited, and one can easily learn and then do maintenance. So in addition to other concrete benefits, some advantages of modularization are: number one, relative ease in maintaining a divisible configuration. If you want to dismantle, it is easy when it is modular configuration. Less time consuming and costly maintenance staff training. When you are removing module, it is less time consuming, and the maintenance staff which you would be using, they would be less trained, or they would be paid less. They are not costly personnel. Number three, simplified new equipment design. When you are using modules, uh, that you can decide uh, to design the equipment new, but you can use those old modules as well, and you can upgrade those modules whenever you want. So, this way, the equipment design is simplified. Like these days in Pakistan, the car manufacturing is picking up pace. So, they are using different modules which are already available in the market. Which engine they would be selecting, which shock absorber they would be selecting, which uh, steering system they would be selecting. Uh, all these things they are available uh, in the market because they are available in the modular form. So lesser time is required to design. And number five, easy to divide up maintenance responsibilities. When it is a modular design, you know which module is having problem, and who better understands that module. So the process is simplified. Number six, lower skill levels and fewer tools are required, as you have to change the module. So inside the module, whatever is the task, but it is easily easy for us to develop skill level, and few tools would be required to replace a module. Existing product or equipment can be modified with latest functional units, replacing their older equivalents. Now, this is the advantage of modular design, that if a module is available, a better module is available. So you replace the old module with the new one, and your machine or equipment is upgraded. Fully automated approaches can be employed to manufacture standard building blocks. Mm, As modules are easily installable, so automated approaches can be made uh, to make that equipment. Easy recognition, number nine, easy recognition, isolation, and replacement of faulty item, leading to more efficient maintenance, thus lower equipment downtime. Uh, Modular design makes this fault recognition easy, and when you can easily recognize the fault, You can easily isolate and replace that faulty module. And if you can do all these steps easily, it means the downtime of the equipment would be reduced. Next is to discuss the modules, whether it should be repairable or it should be disposable. Disposable modules are designed to be discarded rather than repaired after a failure. They are used in situations when repair is costly or impractical. Their advantages outweigh the disadvantages, and maintainable modules require significant expenditure in material, labor, time, and tools. So, it is a decision to be made whether to make the module uh, disposable or repairable. Uh, Usually, when a part is made in industry, its manufacturing cost is less, but when you are repairing it, the repair personnel, they are expensive, and it takes more money to repair it. So you have to make a decision. The important benefit of disposal at failure design include: if you want to go for a disposable module, then the benefits which you may have is: number one, simpler and more concise troubleshooting approaches; smaller, simpler, and more durable modules with more reliable design. As you have to improve only that small module, comparatively small, so you can concentrate on that and make it smaller, simpler, and better. Fewer types of spare parts are required. So inside that module, the number of parts would be less. So maintenance of that uh, would also be less. Reduction in required tools, personnel, facilities, and repair time. If you are going to dispose it off, so the tools required there would be less because you would be just opening that module. Personnel required, so number of persons required would be less. Facilities required would be less, and repair time, that is most probably the replacement time, that would be less. Improved reliability due to sealing and potting methods. So different methods of manufacturing are involved. So these methods can improve reliability. Better standardization and interchangeability of modules. So we can use interchangeability and standardization for those modules. So that was the benefit from disposal at failure or disposable modules. Now, what are the drawbacks? Everything has some advantages and disadvantages, so we should discuss both. So, some disadvantages or drawbacks of failure uh, disposal of module is: number one, an increase in inventory required because of need to have replacement module on hand at all times. If there are, say, six modules, so you should have six modules in inventory, and a module would be expensive than a part, so you have to spend more money in inventory. Number two, inability to redesign disposable modules. So when a module is disposable, you don't redesign it. You redesign for better performance. But if you want to dispose it off, then you don't go for better design. Reduction in module performance and reliability because of production effort to keep them inexpensive to justify their disposal. So as you can see, when you have to make it disposable, you spend less on that. Like the razor which you are going to dispose it of, uh, that is made of cheap material, and when it is reusable, it is made of expensive material. Reduction in available data on maintenance and failure. As it is now about the module, so the data about the failure of part inside the module, that would not be available because you would be changing the module and you may not be repairing the part which has failed in the module. Increase in uncertainty, unnecessary replacements. Sometimes you that module would be working perfectly, but due to some reason, some miscalculation, you may dispose it of prematurely. So, some guidelines for designing modular system are product guideline description. Number one, divide the product or system or equipment under consideration into many modular units. Make modules, parts, components as uniform in size and shape as feasible. It means that they should be handleable. Number two, to the extent possible, design modules for ease of operational testing when removed from the system or equipment. When the module is removed from the equipment, it would not be functioning because it would be taking some input from somewhere and giving output somewhere. So you have to design some test bench where you can easily perform tests on that module. Design all equipment so that an individual can easily replace any failed part. When it is a modular design, we can design it in such a way that these modules can be replaced by an individual very easily. Number four, take an integrated approach to design by considering the problem of component design, modularization, and material simultaneously. Number five, aim to make each module capable of being inspected independently and effectively. Number six, design each module unit small and light enough so that a single individual can easily handle and carry it. Number seven, ensure that the functional design of the equipment is matched with division of the equipment product into removable and replaceable item. Number eight, emphasize modularization for forward level of maintenance to enhance operational capability. Design control levers and linkages in such a way that allows easy disconnection from parts or components, in turn simplifying component replacement process. So these were some guidelines for modularization of the equipment. Let us discuss another important parameter of maintainability, and that is interchangeability. Interchangeability has made uh, big progress because we are making parts and selling into the market, and the users, they are recognizing that this part can easily be used in the equipment. So the nuts, bolts, screws, and different items of such type, they are interchangeable, so you can remove one, insert another. Interchangeability may be defined as the intentional aspect of design Any part or component or unit can be replaced within a given item by any similar part, component, or unit. There are two distinct types of interchangeability: physical interchangeability and functional interchangeability. In physical interchangeability, two atoms can be connected, used, and mounted in the same location and in the same manner. With functional interchangeability, two given items serve the same function. Hmm, I don't know you understand it or not, but when there is interchangeability, uh, that can be functional and that can be physical. From the functional, we would mean that uh, the part which you are changing, it is performing the same function. That is, you replace a pump by a pump. While in physical interchangeability, uh, instead of a pump, you can install a generator. So that is physical interchangeability. Function is different. Next is the basic principle of interchangeability include liberal tolerances in the item requiring frequent replacement and servicing of parts because of wear and damage, that each part must be completely interchangeable with each other similar part, and that the item expected to function without part replacement. Strict interchangeability could be uneconomical. So that is very important and interesting. When you are going for interchangeability, then you have to define certain tolerances. The parts which you are selling into the market as interchangeable parts, uh, all of them should be usable. But as there are tolerances, so you have to reject some parts as well. In Peshawar, there are a lot of uh, factories in which these arms, uh, pistols, and rifles they are made. But here they are not following interchangeability, because in the interchangeability they have to discard certain number of parts. So they are making parts not interchangeable so that they don't have to mm, reject some parts. Now the disadvantage is that uh, the people who are in the manufacturing field, they are not making parts for them. When it is interchangeable, you don't have to make those parts like nuts and bolts. You don't have to make those parts. You just go to the market and purchase them. So this way, you save a lot of time, and also those who are manufacturing, they are manufacturing in bulk quantities, so their cost of production is less. So interchangeability can reduce the cost if the production is large, but if the production is small, it may become uneconomical. So the guidelines for achieving maximum interchangeability of parts or units are: number one, ensure that when physical interchangeability is a design characteristic, there is also functional interchangeability. Second, when functional interchangeability is not desirable, there is no need for physical interchangeability. Avoid differences in size, shape, mounting, and other such characteristics. So when you remove one part, the next part should also be of the same size, shape, so that it is easily recognized and easily mounted. All parts, units, components expected to be identical should be completely interchangeable and identified as interchangeable. Number five, provide sufficient information in job instructions and on plate identification for users to decide with certain level of confidence if two like items are interchangeable. This can be done by the coding of the parts. If the parts are of same code, it means they are interchangeable. Provide adapters to make physical interchangeability possible in situations where complete, that is both functional and physical interchangeability is not possible. In your home, there are some locations where, say, you have to insert a 3-pin plug, and some equipment which you connect there, they have 2-pin plug. So you put an adapter there and convert this 3-pin plug into a 2-pin plug. So this kind of uh, adapters can be used to provide interchangeability, physical and uh, functional. Next is standardization. If you make the parts standard, then its cost can be reduced in the way that many manufacturers would be going for those standards manufacturing. So, standardization may be described as the attainment of maximum practical uniformity in an item's design. Although standardization should be central goal of design because use of non-standard parts can result in low reliability and increased maintenance, it must not be permitted to interfere with advances in technology or improvement in design. When you go for standardization, many manufacturers can manufacture those standard parts, but if you are using those standard parts in your equipment and you are sticking to it, then sometimes you may be sacrificing the improved technology available. So it is not always recommended to go for standardization. Sometimes you have to deviate from standardization, but most often standardization do help. So the advantages of standardization include number one, reduction in design time, manufacturing cost, and maintenance time and cost. Eliminates the need for special or close tolerance parts of components. Number three, useful to reduce errors in wiring and installation caused by variation in characteristics of similar items or units. Number four, useful to reduce the probability of accidents stemming from incorrect or unclear procedures. Number five, reduction in wrong use of parts or components. Six, useful to facilitate cannibalizing maintenance approaches. Cannibalizing. Cannibalizing means उर्दू में इसको कहते हैं आदमखोर जो एक जैसा हम्म, यानी एक स्पीशीज एक जैसी उसी स्पीशीज को खाती है तो दैट इज कैनिबलाइजिंग. तो अगर कोई इक्विपमेंट जो है वो ख़राब हो गया है, वो काम का नहीं रहा, तो उसको भी आप साथ रखते हैं क्योंकि उसमें से कुछ पार्ट्स उठा के आप अपने नए इक्विपमेंट में मेंटेनेंस के दौरान लगा सकते हैं. सो इसको हम कैनिबलाइजिंग कहते हैं कि चूंकि ये स्टैंडर्डाइज्ड पार्ट्स हैं तो एक का पार्ट उठा के हम दूसरे में लगा सकते हैं. नंबर सेवन, इम्प्रूवमेंट इन रिलायबिलिटी. जब ज़्यादा लोग बना रहे हैं, अच्छा बना रहे हैं, तो रिलायबिलिटी भी बेहतर हो जाएगी. नंबर एट, रिडक्शन इन प्रोक्योरमेंट स्टॉकिंग एंड ट्रेनिंग प्रॉब्लम्स. स्टैंडर्ड पार्ट्स अवेलेबल हैं तो बाज़ार से आसानी से आप ख़रीद सकते हैं, स्टॉक लेवल आप कम कर सकते हैं. और चूँकि सबको आइडेंटिफाइड होगा कि क्या है, तो ट्रेनिंग जो उस पे देनी है नए इक्विपमेंट पे, नए पार्ट्स पे, तो वो भी कम हो जाएगी. तो दैट वाज अबाउट मेंटेनेबिलिटी. हमने कुछ इसमें से डिस्कस किए हैं जो हमने यहाँ पे तकरीबन 25 आइटम्स آئیڈینٹیفائی کیے تھے کہ یہ ایکسیسیبلٹی کو بہتر بنا سکتے ہیں. ان میں سے چند کو 4-5 کو ہم نے ڈسکس کر لیا ہے. اوکے، تھینک یو.